Greetings, this is Artie from Artifact Electronics. Today we have a Kawai K3 synthesizer. I recently picked this up. It was cheap, it was local, and the guy selling it actually picked up the phone. That seems to be a rarity today because a lot of people advertise stuff, and when you either call or text them, you never hear back from them. So why do people advertise stuff? I don't know. But anyway, this one went smoothly. I went and I picked it up. Why is it cheap? Or why was it cheap? And that's because there's something wrong with it, which the seller demonstrated what was wrong with it. He even had made some attempts to fix it, but he didn't, and he said he had it for a really long time and he's sick and tired of it and he just wants to see it gone. So here it is. So this is a hybrid synthesizer. Some of the functions are digital, like the sound generation, the oscillators. They're basically playback samples from a real small sample memory, and the waveforms can actually be edited and specified and then saved. Instead of having a nice array of knobs to turn, such as the Oscar, where you basically have a knob per parameter, making real-time adjustments really easy. But this is from the mid-'80s, and they kind of went to the cost-cutting measures and put buttons in. So the way you edit this thing, for instance, is you select a parameter, and it tells you what the parameter is and what the current value is, and then in order to change it, you go to the increment knob, and that changes the value. And let's see, one of the changes on here is that monstrously large volume knob. Originally this had a slider, but those sliders would go bad, and I guess what they did on this one is they put a rotary volume control in there, which, well, it works, but I'm going to look into seeing if I can replace it with an original. Came with a memory cartridge for storing sounds and waveforms, and the interesting thing is that getting a memory cartridge like that, if I were to buy one today, would probably cost more than I paid for the entire instrument. So that was a nice bonus. It's got a pitch wheel, keyboard looks good. There have been some repairs to broken keys, which we'll look at on the inside. But let's have a look and see what's wrong, what's broken in here, see if you can fix it. So here's the problem that was demonstrated to me before I bought it, and that is every sixth note sounds flat, I was told. So what does that mean? First of all, this has 6 oscillators in it. So as you're playing notes, it uses some internal algorithm to assign oscillators to keys. It's not fully clear to me how it does it, but it's easily demonstrable of where the problem lies. So I have a patch, and here's what it sounds like. The 6th note sounds different. Now it's not flat, as he described, because flat to me means that the pitch is off, but rather the timbre is off, or the characteristic of the sound. So they all sound the same. And while we're doing this, we're actually cycling through different oscillators. Now, if we continue this, and again, I don't know the exact algorithm of how it assigns it, but to me it sounds like there's a problem with one of the oscillators, obviously. Going further, to me it sounded like since it's the quality of the sound that's bad, it's probably the filter that's sitting on that that oscillator is feeding, because the pitch sounds fine, but the filter value itself seems to be off, completely off. And to demonstrate that, we can go and play a note. Let's go into edit mode and select the filter cutoff. So now we can go in and change the cutoff. Well, the sound completely disappears, and then as you're opening the filter, so on a note that works, you can change the actual filter value, and there's a single filter value for all 6 voices. So as you're turning the knob, you're actually changing the value for all the oscillators. So we have 2 correct sounding notes, and they're equally affected by changing that. But now let's find a bad, and I shouldn't say note, let's find the bad oscillators, which we can just do by playing some keys. So here's a bad note. Remember, on a good note, we can affect the sound. On a bad one, it makes no difference. Changing the filter cutoff makes no difference. So we have a problem with the filter. Let's have a peek under the hood. Now, one thing I should clarify is, even though there's a single filter value you can change that affects all 6 voices equally, there actually are 6 separate filters. They're all contained in a chip for each channel. So the same value is sent to all of the filter chips. In this case, and again, the seller had done some work on this. You can see here's the filter chips for each voice. And he'd done all the work already by measuring stuff and putting an amp on it and following the sound path. He had determined that this filter chip was bad. And that's, you know, that could be a deal breaker, because these filters, what is it? It's an SSM 2044. These chips are pretty rare and expensive, and that was my first thought. But when I mentioned that to him, I guess he didn't really mention that he had worked on it. Then he got excited and told me about how he had tried to fix it. And what he did was a really good practical approach, and that was he determined that this chip was acting up. So they're originally were all soldered in, so he removed this chip and this chip and swapped them, and the problem stayed in the same channel, which basically told us that it's not the filter chip but some of the support circuitry that is not changing the cutoff on this chip, but it is doing it on all of the other chips. Let's see if we can get a little better look here. Actually, did a pretty clean job of desoldering and socketing those chips. Here and here. But as you can see, there's lots of extra components around them. There's adjustments. There's 3 pots for each of the filters. And there's a procedure in the service manual on how to get this going, and if we can fix it, then we will calibrate everything. But I think we got the problem localized to it is not the filter chip because they were swapped, so it has something to do with the control logic that feeds this one with a cutoff frequency. Here's the part that generates the control voltages to drive the chips. It has two DACs set up in a multiplying fashion, and what it utilizes the way it utilizes this, it basically time slices, puts a value into the DAC, and then uses a sample and hold circuit to save that value, such as over here. The way that works, this is commonly how it's done. What you're basically creating is a whole bunch of little power supplies here. So you feed the DAC with a digital value up there, and then that value gets put into the analog multiplexer here. You select an output on it, so the DAC value flows through past this capacitor and into a simple follower circuit here with the op-amp. This op-amp in this configuration is of an extremely high impedance, so whatever value is here, or whatever analog value comes out of here, gets stored in this capacitor, and it takes a reasonable amount of time for the value to start sagging and bleeding off, but this is updated periodically, and it works very similar to a dynamic RAM memory cell, which has to be refreshed periodically. The difference being that a dynamic RAM cell is either 0 or 1, so you got a lot of playroom in there. Over here, the actual analog value, in this case from 0 to 5 volts, is stored on this capacitor and is available at the output over here, but it still needs to be refreshed because it's going to sag as this capacitor, which is tied to ground, is going to start leaking to ground after a while. But if the refresh rate on this, is reasonably high, the value we see at the output of the op-amp is basically going to represent the original D to A value. And we have a whole bunch of these. But what we're looking at is, you can see VCF1 through VCF6. This generates the cutoff values for the 6 different filters. Now, why are there 6 different filters if there's only one cutoff value, and that the user can change, but there's other values? For instance, you can enable keyboard tracking, which affects the value that you've set for the filter depending on which key you press. Whether you press a low key or a high key, the value is actually modified to make things sound even across the keyboard. That's why we have separate control of all of them. And my guess, my guess is that something in here is not happening. Here, voice number 2 is the one that's misbehaving. So the signal path, and again, we can kind of exclude the DAC and the analog multiplexer over here, because the other 5 filters driven off of this work correctly. So that kind of leaves us with the actual op-amp over here that is specifically for the bad voice and whatever circuitry it feeds. So here we can see the analog value coming from the output of this op-amp over here and going through the bus. And then the way this is drawn over here, it shows you that this is one of 6 filters, and these lines over here indicate that there's basically 6 filters here, but we're only showing 1 because the other 5 are identical to it. But it does show you the control lines branching out here. And if we look at VCF2, it goes over here. It really doesn't matter because they're all the same, but what we have to do is look at the circuitry that the cutoff value we're sending to, what happens to that. So it comes in over here, gets conditioned, and there's also a trimmer pot over here that offsets it. So what you can do is during the adjustment process, you adjust the value here, or the value that reaches the filter chip, so that it's the same for all of the chips. So in an ideal situation, as you're playing keys on the keyboard, you should not be aware of any differences in oscillators, so everything sounds even. And if these are misadjusted, then you will have an effect similar to what we're seeing now, where, for instance, every sixth note, just the timbre, the character sounds different, and that's usually a result of not having adjusted all 6 filters, trimmed all 6 filters. There's 3 trimmers per filter, which is the cutoff, the filter offset, and the peak adjust. And again, if we get once we get this to work, we're going to have to go through and do the recommended calibration routine, so they all sound the same. But back to what we're looking at, there's really not a whole lot. I've gone in and I measured, it could be an open resistor here somewhere. Of course, I measured the power supply voltages. Everything is good. My big suspicion was this cap over here. And what this cap does is that if you have abrupt changes in the control voltage for the filter, it will smooth that out a little bit. So that'll reduce a stair-stepping effect when your control voltage jumps in large steps, because this will smooth it out and you won't hear the filter jump or stair-step, but rather have it smoothly change. So again, this is, I observed this capacitor. It's a regular, we'll look at it in a minute, but it's a regular electrolytic. I poked around in here, and what I found was that the value coming in right here was changing. As I changed the value on the preset, you could change the value between a value of 0 and 99. As the voltage was changing here between 0 and 5 volts, it was getting here, but then it was getting lost. I'm not exactly sure. It was getting lost. See here, it feeds into pin 13 on the filter chip. And what I found was there was a constant value of 500 millivolts on this chip, which exactly describes the problem we're seeing, is because the cutoff control voltage never changed. Now I went in here and I measured everything again. Everything looked fine. But then a funny thing happened. I think at one point my probe slipped or something. And what happened was all of a sudden I saw this value, the final value feeding the filter, starting to change as I was changing the parameter on the front panel. And I really don't like fixes that way, but it worked. It worked for a while. All 6, this one worked properly, was affected properly, all the voices sounded the same. And then I turned it off and started cleaning the instrument and turned the instrument back on, and the problem was back. This one basically went to no cutoff control again. So I went back and started poking around some more. So this is the 1 microfarad cap we looked at. This is basically where the values from the analog multiplexer are coming in. And this is where I poked around, and eventually the signal goes to a couple more resistors. Here's the trimmer, and it enters this chip at pin 13. And at pin 13, the value was not changing. So let's find the bad note again, because I found something really interesting while poking around. There's a bad note. And here's what I found. All 6 notes work when I press on it. So, what does that look like? I did mess around with it a while off camera, And this is kind of the spot that I have to press down on. I have to press it pretty good for it to change, but my guess is that we have a cold solder joint in there. Somewhere in that path between the multiplexer that generates the control voltage and pin 13 of this chip. So I guess it's time to take this board out, observe and see what's going on underneath, and reflow some joints and see if that'll fix it. So basically my suspicion was there was this jumper wire over here. It was probably factory installed. From here, hello, camera decided to zoom out. Stay. That was going from here to here. I reflowed these connections. This is the capacitor and the small resistor over here where the control voltage is coming in. I reflowed this area. I actually pulled the cap and checked it. It's okay. And I don't just replace things, but as you can see, there's a lot of electrolytics on this board. And at one point in time, they would all need to be replaced. But for now, we're just going to fix this. Here's the adjustment for the cutoff frequency, control voltage, reflowed under here. This is pin 13, 14, 13, some more stuff over here that all got reflowed. And really looking at it, I didn't really see anything suspicious. But here's basically the path of the control signal comes in here and then gets distributed to the chip, which you can clearly see both were replaced and socketed. And that's about it. I think it's time for this thing to go back in and see if we made any difference. I reinstalled the board, plugged the connectors and didn't screw it in place, and played some notes, and nothing changed. Same problem. Whenever pressing on here, it would fix it. So here's what I found. I basically put it back on the bench and did some continuity testing for the entire path of the control signal for filter 2. And let's see, can we see that? We can kind of see that. It comes out of this chip. This is the op amp. It's a TLO82, but it's in a SIP package, so that should be easy to get nowadays. But, you know, same thing, dual op amp. So it comes out of this chip, and then it goes to a via over here. You can just barely see the edge of it. Jogs over to here, which is another via, and from here it goes to the capacitor and the resistor that passes the control voltage on to the filter chip. Now what I found when doing my continuity tests was that this via was bad. So the signal was getting here when I was measuring it from here to the op amp. There was continuity, but there was no continuity over here, which is the initial resistor that the control signal goes to. And it turns out that since this is an older style board, the vias aren't plated through. And they completely depend on, when the board's wave soldered, that solder is placed in the vias and makes the top to bottom connection. There was very little solder here, and as a result, this via wasn't connecting to the bottom of the board. So essentially adding some solder to this, heating it and making sure that the top to bottom connection was there, well, that fixed it. So now we can test all the notes. Intermittent key contact. So it looks like we're back to full functionality. So that's a filter sweep. Basically, the control voltage controlling the cutoff is gradually raised, and it's playing something with 6 notes in it. Hear the filter opening and closing, and the voices all kind of sound the same. Oh wow! We heard this one in the Oscar demo. Sci-fi music. Electro snare drum. Toy helicopter. Looks like it came back to life. And there you have it. She's alive again. To summarize, we didn't have enough solder in one of the vias. It's an old style via that isn't plated through, so it depends on the solder, and that probably lack of solder in there probably worked out of the factory, but it cracked under road use, and all it took was a small amount of solder, a medium amount of heat, and a lot of patience to get this guy fixed. Thanks for watching. Like, subscribe, and comment, and we'll see you next time.